This is Mrs. Fraser, and in this video we are going to look at how to solve a system of inequalities by graphing. So if you will find your graphic organizer that you received in class, and you're going to glue that whole sheet down and to your notebook and take notes as you watch the video. Pause as necessary to keep up with the video, but tomorrow hopefully, this will help you be successful in class to have an idea of what a system of inequalities are. So the definition of a system of inequalities is when you are solving two or more linear inequalities simultaneously, it is called a system of inequalities. You can pause to write that definition down. And then we're going to go over the steps to solve for a system of inequalities. So to solve for a system of inequalities is very similar to how we graphed a system of inequalities. So the first thing that we're going to do is we're going to solve for y. By solving for y, we can easily graph our slope and our y-intercepts and determine where we are going to shade our inequality. Our second step is to graph a solid or dotted line. So we have to remember our symbols for a solid or dotted line. You can refer back to your systems, or you can refer back to graphing linear inequalities for that. And then for both of them, we are going to shade. So far, there's really nothing different to solving a system of inequalities, but we're shading for two of them this time. And then last, we're going to determine where both are shaded. Where both are shaded is where we are going to find our solution. So the solution to a system of inequalities is the shaded area that satisfies both inequalities. So get all of that down and then come back to the video and we'll do an example together. Okay, so looking at our example, I have y is greater than or equal to 2x plus 1. And 3x plus 2y is greater than or equal to 8. So I can see that one of my inequalities is graphed, or one of my inequalities is solved for y, but the other one is not. So I'm going to go ahead and solve my second inequality for y. So I'm going to subtract 3x from both sides. And I'll have 2y is greater than or equal to 8 minus 3x. I'm going to divide by 2. And I'm going to make sure that what I'm dividing by is not negative. Because remember, for inequalities, we have to flip our symbol if we divide by a negative. So that doesn't change when I'm graphing. That would be the same. But I'm not dividing by a negative. I'm just dividing by 2. So I have y is greater than or equal to 8 divided by 2 is 4 minus 3 halves x. So now I'm going to graph a solid or dotted line for each of these. So I can see that for both of them, I'm going to have a solid line because my greater than or equal to and less than or equal to would be a solid. And my less than and greater than would be a dashed or dotted. So let's start with y is greater than or equal to 2x plus 1. So I know that 1 is my y-intercept. And yes, you could graph these on your calculators too, but it's really good to be able to know how to do it without. And I'm going to switch colors so we can see a little bit better. I know my rise or my slope is 2. So I know I'm going to go up 2 and over 1. Up 2 and over 1. And from here, I am going to graph a solid line. Okay, looking at my next, I can see that my slope is -3/2. Switch colors again here. And my y-intercept is a +4. So I'm going to start my graph at a +4. And I'm going to go down 3 and over 2. Down 3 and over 2. And again, I'm going to have a solid line. Okay, so now I need to shade for both. So let's start with my green line. My green line is greater than or equal to. So I'm looking where I would shade for it to be greater than or equal to. I know I need to shade above the line, but I also could use my test point. So I'm going to use my test point of 0, 0, my origin. So I'd have 0 is greater than or equal to times 0 plus 1. So I have 0 is greater than or equal to 1. Well, 0 is not greater than or equal to 1. So I don't want to shade where 0, 0 is. Let me mark my test point. Instead of since this is false, I'm going to shade on the other side. Okay, so now looking at my blue line, I'm going to do the same thing. I'm going to go ahead and plug in my 0, 0. So I'm doing 0 is greater than or equal to 4 minus 3/2 times 0. So I can see 0 is greater than or equal to 4. Okay, so this is also false. 0 is not greater than or equal to 4. So I don't want to shade where my test point is. I'm going to shade on the other side of that line. And what you're going to see, and I'm going to grab my highlighter so I can be sure that you really see it, is I have an area where both of these are shaded. And this is my solution. Any point within this is my solution. And in this case, any point on the line in that space is also my solution because we have solid lines. So let's give some examples of some solutions for points. So one solution could be 0 and 6. Let me get a thinner line there. 0 and 6. One solution could be 0 and 8. One solution could be 2 and 8. And then I could also have a solution in that area that's on the line. So I could have a solution of 0 and 4. I could have a solution of 2 and 5. And any of these, if I would plug them in, I would get true statements for both inequalities, meaning it's true for both of them. This is where it would satisfy both. So tomorrow, make sure that you have this glued in, and we will begin a discussion and practice some more about a system of inequalities.